got another year and a half to go on a government contract. He paid Intel $10 billion to keep building Itanium. That's the only reason it's still floating on the marketplace. No buying it, except the government, of course, with money. That might make you feel better. There's stuff out of them. Thousands, even Spark was able to sell that much stuff. So, millions, the only guys selling millions of chips are Intel and Power. The only guys selling tens of millions of chips, Intel and Power. That's what it takes. Now, IBM is not selling tons of millions of chips because they sell that many servers. Intel sells that many servers and laptops. I'm making that kind of money because they are now the leading embedded manufacturer of technology. They're running in cell phones, they're running in routers and gateways, they're running in storage systems, all sorts of kinds of technologies. All the gaming machines, ASE, their high-end storage is running Power. These are Power chips. Cisco routers, they're running Power chips. There are 32 Power chips in a BMW 7 Series, for instance, okay? Just to give you some feeling for why they can drive that kind of volume. That allows them to do R&D. R&D allows them to build new chips. Those chips allow them to build brand new fabrication plants. It costs $5 billion to build a fabrication plant. You pay for that if you can't sell tens of millions of chips out there, okay? Remember what McGuire said? Show me the money. Not about the technology. It's about the money. That's how simple this is. And that's where it's coming down. Even Oracle is not going to be able to sell enough Sun chips or Fujitsu chips to keep that going. The latest is the Power 7, and the reason I'm going to talk about Power, I'm going to talk a little bit about Intel. You guys probably know a lot about Intel. You probably studied Intel, you probably have a lot of Intel on site, you probably work with Intel. Not very many folks really understand what Power has to offer, because that's your other choice. I'm going to try to take you through what the trade-offs are when you decide to either go with Intel or with Power as you make this migration. By the way, going from ASE 12 to ASE 15, really good time to look at a new architecture. One that can run it at 4 or 5 times the performance of what you're currently running on, especially if you're running on old Sun boxes. I love going up against old Sun boxes. They aren't painted nice anymore. It's not just the Power 7. This is a family of chips that started back in 2001. 20% of the guys that designed this first chip came from Poughkeepsie. They're mainframe guys. This is mainframe technology we got on here. All through Power 7. Power 8 is already underway. In fact, it's been taped out. Well, they just started to tape it out. You'll see that probably about 2013. So, and by the way, our discussions right now about a Power 9. So the family of technology will continue on, just like Intel's family of technology. The difference is, every 3 years changes this technology. Every year and a half, they kick up the clock. They do some things. Every 3 years, they come out with a new technology. Okay? Intel's life cycle is about 5 years. Intel remains about 5 years behind IBM in their technology, and I'll show you that as we go. So, what are the advantages of doing Power over Intel? Well, 3 things. Quite frankly, performance. And the Halem is a very good chip. Intel's done a great job with that technology. It still doesn't have the kind of performance that IBM's built into Power 7. Performance it lowers your costs and allows you to scale up to gargantuan size systems. The Power 7 will scale to 32 cores, or 32 sockets by next year. The biggest Intel boxes you're going to see out there are 8 socket. That's, of course, from IBM, who does 16 socket Intel. Another secret that nobody knows. The value of scalability. All these centers that get overrun, putting in, people are telling me we're doing blades. A blade is a 1U pizza box turned on its side. Okay? What's the problem with that? Instead of having 10, 14 or 30 or so, depending on how courageous you are, in a rack, now you put 14 or 16 in a much smaller compartment. Guess how much heat that generates? Guess how much power that thing draws? Difference. Customers will say, we can't go to blades because if we concentrate blades in our data center, the hot spots will shut us down. We can't manage the heat coming out of a blade. Advantage is virtualization. Now, you can virtualize Intel boxes. VMware is a very good product, and we do a lot of VMware. solid product. If you're virtualizing Windows, VMware, in my opinion, is the only viable choice. I know Microsoft has Hyper-V out now. Zen is available. We even have one from the GNU guys. But in terms of maturity, support, market reliance, without VMware is the tops if you are going to virtualize Windows. If you're not looking at Windows, if you're looking at Unix, by far the best solution is the Power Virtualization. What does it give you? Flexibility and utilization. Why flexibility? Because you can turn on the server in 15 minutes. You can provision, start, load, and run a server in 15 minutes. Try any Intel architecture. And in terms of utilization, we're running these things at typically 70%. We have customers run them at 90% on occasion, and that's a little distressing to us. We have a lot of confidence in them, but 90% is kind of stretching it. Intel run on the average 5% utilization. Now, a really solid Sybase platform, bang away from a whole bunch of applications with a whole bunch of users, you might be pounding away on average at 20 to 25% if you're really pounding on your Sybase database. That's what you're going to see. Now, you'll get spikes. For the most part, the average will be 20 to 25% if you're really pounding on it. If you're running a Windows box at 5%, what does a Windows box cost? A two-socket Windows box. What does it cost? $5,000. Two-socket, $5,000. Do you know, ever since the first two-socket came out, we've been paying $5,000 for it? And that's 15, 16, 17 years ago? $5,000. So if you're getting 5% utilization out of a $5,000 box, how much does it cost to get 100% utilization out of that box? $100,000 bucks. 20 of them. 100% of one. That's a proposition. But that's what's going on all over the world. And last but not least, reliability. Remember I told you this thing was built by mainframe guys? Well, they're putting mainframe reliability in. It is not quite there yet. Very, very close. We get closer every year. This is the Halem chip. Pretty interesting stuff. This is the new 8-core EX, they call it, the 7500 family. Very solid technology. These QPIs, those interfaces that AMD came up with, they call them hypertransports. Intel copied it. I'll tell you, I know that because I did some consulting with Intel in 2001 under a very NDA, and they told me all about this. They were basically copying everything AMD did. How did they get away with that? Because Intel and AMD signed an agreement in '71 that said we will share all technology in perpetuity. Perpetuity is a long time. Now, these were engineers writing a contract. So what else would you expect, right? When our chip at Intel, making gazillions of dollars, AMD said, well, our bit slice stuff is interesting, but it's not doing anything. Let's build Intel chips. So they did. They started building Intel chips. Intel said, you can't do that. They said, sure we can. It's in our agreement. So Intel sued them, came this close to suing AMD out of business, but AMD won. So they still have to share all technology in perpetuity. So that means not only everything Intel's doing, they have to tell AMD, but everything AMD's doing, they have to tell Intel. So we came out with the Optron, started building the Optron, Intel said, wow, we probably ought to cover our bets. So they were rolling out Itanium. They started a project called Yamhill to do exactly what AMD was doing. But of course, they had to do it better. Well, it didn't come out quite in time. AMD now is doing their hypertransports on a 6-core chip. Tried putting 8 cores on a chip, but they couldn't get it to work. So they're on a 6-core chip. Now they have a 12-core chip, but it's really not a 12-core chip. It's actually 2 6-cores lashed together. Okay. But AMD is driving this. Intel came out with a better interconnect, the QPI, stronger memory interface. This is a serial to parallel interface for memory, and they've got 2 of them on the chip with 4 channels, 2 in each one of these. 8 cores, 24 meg of level 3 cache built onto the chip. This is SRAM, static RAM. The problem with SRAM is it's a little bit expensive, and it uses 6 transistors for every bit. Because it takes Intel 2.3 billion transistors to do this 8-core chip. Okay, that makes it expensive, and it makes it hot, and it makes it difficult to cool, and it draws a lot of power. 2.3 billion transistors. Keep that in mind. IBM's power technology, very similar technology, but the things in red are differentiators. IBM is doing their 8 cores and 32. Where's my